create the practical and hands-on learning opportunity for our students who are part of the master course in electric vehicle powertrain design and validation, we have created an extensive test facility. As a part of this test facility, we have the chassis dynamometer, which is an inertial type, and we also have the in-house developed the electric vehicle, which is having a full-fledged data acquisition system as well, which works on the CAN-based systems. And then we have the data that is also being captured at our desktops and laptops. And then we also have a data visualization toolbox that catches along with the chassis dynamometer. With the help of all of this setup, at the very basic level, we can understand the tractive requirements of the vehicle, such as the wheel torque and the wheel speed, and deriving with respect to that the vehicle speed and the power output at the wheel as well. In continuation to this learning that the learner will get, we can understand to achieve the desired torque or desired power output at the wheel, what is the amount of the energy that is required for the battery or also for the motor as well. In the backward way, we can understand the motor torque and the motor current to meet the output requirement of the overall vehicle. In understanding all of these things, we have the CAN-based data logging devices which hooks up along with the battery management system, also to the motor controller. So that the data comes from the motor controller, also the battery management system via CAN communication protocol, and directly comes to data logging devices. With the help of these devices, we are able to log the values, and then we can put them into our computers and analyze what exactly the requirements at the battery are also at the motor as well. In continuation to this, we can limit a lot of different parameters, such as inside the motor controller, which we typically call as a controller tuning or controller characteristics, where we are able to set various different limitations at the motor level or also at the battery level, such as the motor maximum current or the responsiveness of the motor or various delay parameters also we can set, and then the region parameters. When we set all of these parameters, we are able to study how does the motor behave or how does your vehicle behave with respect to all of the set parameters. In the same way, we can set the various different parameters inside the battery management system. When we set the parameters, we can get to know if the motor is trying to draw the current above a specific limit, how exactly the battery management system will cut off the output to the motor or limit the output to the motor. In this way, what exactly you are able to learn is to know the characteristics of the overall vehicle. We can call it the tractive characteristics of the vehicle, and also the characteristics of the motor and the characteristics of the battery as well. To making all of this happen, you get a very broad level picture of the powertrain and its characteristics. When we learn all of these things with the help of our complete practical lab, you can acquire the data and then we can compare all of these results with respect to your simulation results as well. So when you do that, you will be able to derive the comparison of your test results, also the simulation results, and that gives you a proper practical exposure on what exactly these results are, how does these results vary in terms of the real-time testing, also with respect to simulation testing. With respect to these great details, the learner gets a confidence on how exactly the vehicle is tested and the vehicle is going to perform with respect to our real-time testing scenarios, how you can tune the motor controller and also its characteristics and study the output characteristics of the vehicle as well. By end of this whole 2-day learning activity that we conduct at an offline training program, you get a complete confidence and an exposure to the vehicle testing and its characteristics as well.